Okay, welcome to this second video on log and exponential functions. We are going to quickly talk about the natural logarithm function. That is a function with base e. So there's a lot of information about e, and I'm not going to get into it here, but we have dealt with it previously about this exponential function and the fact that the derivative of e to the x is e to the x. And then, of course, the understanding then comes that one function is the inverse of the other. Ln x and y equals e to the x are inverses of each other, as you can see on that graph. The definition of ln x actually comes from the derivative. And if you look at the area underneath the curve 1 over t, if you like, from 1 to a certain x value, that is the value of ln x. So as we increase the area under that curve, you can see that the area under the curve is the same as the value of the function, the natural log function. That's the basic definition of what the natural log function is also. Because they're inverses of each other, these things work. So if you undo e to the x by putting an ln in front of it, you get back the original x. If you go e to the power of ln x, e and ln undo each other, you get back to x. So you know the equivalent for base 5 would be 5 to the power of log base 5x is x. Or you could say log base 5 of 5 to the x is also x. Okay, so it's just understanding that those two functions are inverses and undo each other, much like if we went the square root of x squared. Okay, we understand that square root and squared are inverses, and this is the same thing, the equivalent thing with logarithmic functions. Okay, so one thing I'm going to do in this video is talk about the change of base formula. This is pretty simple, and you can see in these examples here, if you understand your log laws and understand how to manipulate them, then these questions become really, really simple. So by expressing all of these numbers here, 8 in this case here, 25 is in this case 216 here, expressing all of these numbers as powers of 6 or 5 or 2 makes these questions really easy to do. There's a formula we need to know. It's called the change of base formula. So if we have log base 2 of 8, that's easy. 2 to the power of something equals 8. We know that one, that's 3. Nice and easy. But what about if we had log base 2 of 7? Not so easy. The number's a little bit less than 3, but that one there is a lot harder to do. So sometimes our calculator, and I think our calculators do have log base 2, but we need to understand how to write log base 2 of 7 in terms of a logarithm that we do know. So log base 10 or log base e. So really simple. If I call this x, that's what we're trying to find, and I convert this into a indices statement. So this is 2 to the power of x equals 7. If I now solve that equation by taking logs of base sides, I get this, and then x is going to be log 7 divided by log 2. Okay, now here it doesn't matter what base logarithm I'm using, so I could be using base 10 or e. I'll put base 10 down here. It doesn't matter which one I use, that is the answer to what x is. So in general, log base a of b, as you can see from the example, just gives us log b over log a. You could also say that that's ln b over ln a also. So that's the change of base formula. Okay, so just have a look at, there's a number of questions that I've got on here that I want you to have a go at, and there's just a couple here that would help us with this. So have a go at this question here. Express ln a squared b cubed over root c in the form k1 ln a plus k2 ln b plus k3 ln c, where k1, k2, k3 are rational numbers. So that's using your log laws to kind of break that down and understanding your log laws, how to come up with an expression that looks like this. So the first question on the video is to try that one. Second question. This is one where we're going to use our knowledge of index rules here to try and get this into a form that we can work with. This one here looks really tricky to start with. 3 to the 2x plus 1 and 3 to the x. How do you start solving this? If you start taking logs, you run into difficulties. The secret in this one is treating this as a quadratic equation in 3 to the x. And in particular, the trick is being able to break this down. So let's just see if this makes sense. I'm going to get you started. 3 to the 2x plus 1 is 3 to the 2x times 3 to the 1, because we know in this case we add the powers to 2x plus 1. And 3 to the 2x we could further break down as 3 to the x squared, couldn't we? Yeah, it's because when we multiply the powers, yep, that's right. So we've got 3 times 3 to the x squared. If I just write the rest of the question, now we've got a quadratic in 3 to the power of x. So the second question here is to finish off that question there. Using logarithmic functions. So let's look at this first one. ln x plus t equals 2 plus ln x. Okay. Right, now it would not be correct to try and undo the ln function here, go e to the power of both sides, which is the inverse of ln, and we get into all kinds of problems because this is what I see people write. E to the ln x plus 2, which is cool, equals e to the 2 plus e to the ln x. Hopefully you can see that that is completely wrong on the right hand side there. Instead, what we need to write is this, e to the 2 plus ln x. Now that's correct. We've gone e to the power of both sides. That's what we need to do to undo this natural log function, e to the power of. So on the left hand side there we just end up with x plus 2. That's easy. On this side here a little bit trickier. Remembering our laws of indices, that gives us that. And I think if you work backwards, kind of from there to there, it makes more sense looking at it that way. When we're multiplying with the same base, we add the indices. Okay, so now that we've got that, on the right hand side we've got e to the power of 2. E to the ln x is just x. So we've got x plus 2 is e squared x. If I now subtract x from both sides, so I've got e squared x minus x equals 2. So now we've got a common factor on the right hand side, and now we can get x on its own. X is 2 over e squared minus 1. It does say 3 decimal places, but I'll just leave it in an exact value. In a lot of tests and exams that you have to do this, they definitely ask you to give your answer exactly. Okay, here's another one. Similar to the one that you've just done earlier in the video, so I'm not going to go through this one, but another one that looks like a quadratic equation in 3 to the power of x. So last question I want you to try is this one here. Solve that equation. 2 ln x plus 3 minus ln x equals ln 2x minus 2. That's the last question.